Hi, I'm Shashwat. I hope you are having a really great day. In the previous episode, we covered Z-depth pass in detail. If you want to watch that episode, the link will be provided in the description box below. In this episode, we are going to cover position pass and deep pixel compositing in Fusion. And as you can see here, in Blender, I'm using one of the scenes from my animated films, The Anti-Magic Suit. And if you're interested in watching the short film, you can click on the link above, or the link will be provided in the description below. Here you will see all the passes that I'm exporting. This is the Z-depth pass, and this is the position pass. Now let's go to Fusion and start using these. Fusion is primarily a channel-based compositor. What that means is it uses RGB channels to encode and decode data such as Z-depth or position pass. It uses RGB color values and assigns them to various axes to understand where a 3D object is in a 3D space. One of the main important tools of Fusion is called the channel Boolean node. What the channel Boolean node does is that it applies a variety of mathematical and logical operations on the channel of an image. Basically, what it does is that it uses the channel of one image to modify the channel of another image. We go over to the tools bar area over here. We can see that this is the channel Boolean node. So let's load it into the node editor. These menus represent the 4 color channels of the output image. The way this node works is by using one image's channel to modify another image's channel. So I have 2 images here, a gradient 1 and gradient 2. So let's connect the gradient 1 into the background input of the channel Boolean node, and we will connect the gradient 2 into the foreground input of the channel Boolean node. And then let's load the channel Boolean node to, let's say, viewer 1. And we can see that we are getting gradient 2 as output and not gradient 1. But the only thing we want from gradient 2 is this red strip over here. And we can do that by going over to the channel Boolean node. And we're going to leave 2 red as it is. And let's see what happens when we change to green to do nothing. And also to blue to do nothing. And we can see that it has transferred red data onto our gradient 1 footage. And we can apply a variety of mathematical and logical operations on the channels of an image to create the effect that we need. We can change red to do nothing, and to green we can add red data. So now green is being replaced by red, and we can make all of these channels to take red data. So currently all of these channels are now taking in the red data from our gradient 2 footage. We can change all of them to green, and now all of them are taking green channel. They are being added on because we're using the add operation, and we can select all of them to do nothing. And if we go over to the aux tab over here, we can use these additional channels to feed data into our composition. For example, if we want to create a Z-depth pass, we can feed in Z-depth data to our scene, and we can create a depth of field effect in our composition. We can go over channel Boolean node in detail in another episode, but for now, this is what the channel Boolean does. Every 3D software and renderer has its own channel and coordinate system, the way it encodes various information and outputs various passes. Let's have a look at some of these passes. So these are some of the passes that are rendered out from Blender EV. Beauty pass is the final combination of all render passes with everything included. It is often referred to as a final render from a 3D software. Diffuse direct contains lighting coming from all lights, the background, and even the ambient occlusion of a surface. The color pass contains all the color and texture data without light, shadow, or specularity. Specular direct contains specular or glossy information coming from light sources or HDRIs. Specular color contains the inherent specular or glossy data of a particular object. Transparency pass has information regarding transparent objects. For example, this wine bottle over here. shadow pass contains shadow information present in a scene. The ambient occlusion pass creates the deep shadows you find between cracks and seams and helps to create a more realistic render. Normal pass is a pass that we can use to relight the scene in post if needed. A Z-depth pass is a grayscale image that we can use to create a depth of field effect. It contains depth information in each pixel of the rendered image. Now, the position pass. It is an image where each pixel's RGB color value represents the XYZ coordinate of the corresponding vertex in the 3D world space. But let's dive a little bit more deep into it. A 3D software assigns RGB color data to its various axes. In Blender, we have X-axis which is colored red and goes side to side. The Y-axis, which is colored green, moves forward and backward. And the Z-axis, which is colored blue, goes up and down. While in Fusion, the red axis moves side to side, the green axis, on the other hand, moves up and down, and the blue axis, which is the Z-axis, moves forward and backward. So this is something one needs to keep in mind while compositing in Fusion. And earlier we said that Fusion is a channel-based compositor. What that means is that it encodes and decodes 3D coordinate data as RGB values. So every pixel in a position pass contains XYZ coordinate data. When we move our cursor on any area in the position pass, we can see that there appears XYZ coordinates down there. Each pixel contains specific coordinate data of the 3D space. So first, let's recreate this beauty pass and get as close to the beauty pass as possible. And then we can go ahead and modify it as in how we need it. So let's copy these nodes over onto the other side. And we will be using the channel Boolean node to connect them. We will first multiply the diffuse direct with diffuse color and glossy direct with glossy color. Then we will add the output of the two channel Boolean nodes using another channel Boolean node. So let's bring in a channel Boolean node. And we will first connect the diffuse color to the background input of the channel Boolean, and then we will connect the diffuse direct to the foreground input of the channel Boolean node. And in the channel Boolean settings, we will leave the RGB as it is. Instead, we will change the operation from copy to multiply. And we will do the same for the glossy pass. Now let's add another channel Boolean node. We will connect the output of the color and the glossy channel Boolean node to it. And in the operation, we will use add to add the two passes together. Now we can see that there are certain areas that are too bright. So let's go to the settings tab and just blend it slightly. Okay, now let's add transparency pass to the composition. For this, we can use a merge node. With this, we can see that our composition is now looking close to the beauty pass. Now let's come to the part that we have all been waiting for. Let's add a depth of field to the composition. So first, let's copy and paste a Z depth over here. And if you remember in the previous episode when we created the depth of field for the 3D scene, the depth of field information was already encoded into the image. And so when we use the depth blur node, it would automatically create a depth of field. But what should we do when our composition has no native Z depth information encoded into it? In that case, we have to somehow feed this Z depth data into our composition. So first, let's load a depth blur. Right click in the nodes editor, go to add tools, Deep Pixel, and we can select depth blur. Another way to get depth blur is by pressing shift space in the keyboard and in the search area type depth blur, and we can then click on that. Or we can go to effects, tools, Deep Pixel, and select depth blur from over here. Now let's click on the merge node and let's go up here. And if we click on the drop down icon, we can see that there is no Z depth information. And if we connect this merge node to the depth blur and load it into the viewer, even if I adjust any parameter in the depth blur, nothing will happen. So to add Z depth information into a composition, we will need to use a channel Boolean node. Now there's two ways we can connect a node in between our composition. One is the traditional method. You connect the output of the merge node to the channel boolean node and then connect the output of the channel boolean node into the input of the depth blur. The other way is to click and drag the channel boolean node over onto the wire. Press shift on the keyboard until the wire turns blue and green or yellow. Then drop the node and it will automatically connect in between the two nodes. Now connect the Z depth pass to the channel boolean node. And let's load the channel boolean node into the viewer. And we see that only the Z depth information is being shown. To correct this, in the channel boolean node, set the RGB channels to do nothing. Now, let's go to auxiliary channels and switch on enable extra channels. And here we are going to change the Z depth and Z buffer from do nothing to lightness foreground. Now if we go back to the RGB channel area and click the drop down button, we can see that Z depth data is now incorporated into our composition. Now select depth blur and load it into the viewer. And now if we click and drag the sample picker and move over any area in our composition, we can see a box appear which shows the Z depth and Z coverage value changing. So let's select this cake over here. Let's leave the filter to box for now. It has a type of blur effect and box blur has a fast computation. But for better quality we can use super soften, which is like a Gaussian blur. The blur channel is asking what channel do you want to take the blur information from. In this case we want to take it from the Z depth. Lock X and Y basically locks the blur size to be uniform, and if it's on, the X and Y will move together. If it's off, we can independently change the blur size to create very specific effects. Here we will set the blur size to 10. The focal point sets the area where the focus should be. We can either set the focus manually or we can use the sample picker to automatically set the focus, sort of like an autofocus in a camera. The depth of field is used to determine the depth of the area in focus. And the Z scale can be used to soften or sharpen the boundaries of the blur. So we'll set the depth of field to 1 for now and set the Z scale also to 1. In the viewer we can see some depth of field effect happening. So now let's change the depth of field to 0.1. And now we have a more shallow depth of field. Now if we use the sample picker and move anywhere in the scene, we can see that now that particular area is now in focus. Now let's move over to the cup, and now the cup is in focus. If we want to focus on the burger, then the burger will be in focus. So this is how we use Z depth in our scene. Now let's load the position pass into the viewer. This is what our position pass looks like. The position pass is a 2D representation of a 3D coordinate space. The various colors are the RGB channels which are mapped to various axes in the 3D space. Over here, the X is mapped to the red channel, the Z is mapped to the green channel, and the Y is mapped to the blue channel. And the position pass saves these XYZ coordinate data inside each of these pixels. But currently there is no position data inside of a composition. To implement it, we can either go the channel boolean route and add a position data that way, or since this is an EXR file and there is already position data embedded inside of it, we can go to format, and here we can see that red is taking the X position data, green is taking the Y position data, and blue is taking the Z position data. And now if we scroll down, we can assign the same data to the X, Y, Z channels. And now we can see that this is the X axis, this is the Y axis, and this is the Z axis. But remember what we said earlier? The Y is facing upwards and the Z is facing forwards. And over here if we look at the Y and Z, we can see that they are interchanged. So let's correct that. We will switch the X and Y position in the position channels. And do the same for the RGB channels as well. And this is what the correct data looks like. The Z axis, the y-axis, and the x-axis. Now let's see how we can use this position data in our scene. The most obvious way to use position data is to use it as a mask for our color correction. So let's load a color corrector into the scene and make it blue. Now the entire scene is blue. But suppose we only want to turn this orange into blue. That's alright. All we need to do is to load an ellipse mask, connect it to the color corrector and position it into place and soften the edges a little bit. So now we have a blue-orange, whatever that means. But if this was a moving sequence, where the camera is dollying from left to right around this point over here, we'll have to constantly adjust the mask and use tracking to stick the mask into position. But what if we want to turn this orange into a blue color? What do we do in that case? So this is where position pass comes in handy. And what we are going to do first is to load one of the tools of position pass. So right click, go to add tools, position, and select volume mask. The volume mask tool is used to create volumetric masks from images containing XYZ position channels. And using the picker, we can move this mask anywhere into the scene and highlighting that area. We can change the scale of the mask. We can soften the mask. We can change the shape of the mask from square to circle. We can apply non-uniform scaling to the mask to create very specific types of masks. And we can also rotate the mask in various axes. Now currently, we can see the position pass image as well. So to hide that and just use the mask, we go to color and select mask only. Now only the mask is visible and we can feed this mask into the mask input of the color corrector. And we can see that the entire masked area is now blue. Now let's use this mask to select this orange. So first we will make the mask into a sphere, then reduce the size, then use the picker in the translation to select the orange. Now we can further adjust the mask size and position. Finally, let's just give it a slight soft edge. Now we have a blue colored orange in the scene. And we can use this same color corrector multiple times. So let's make this orange blue as well. Now let's duplicate the mask and we can merge these two using a merge node. But what if we want to connect multiple masks to the same color corrector node? In that case, we can use Fusion 19's new multi-merge tool. So let's load the multi-merge node and first connect these two masks together. Then replace this mask with the multi-merge. Now let's use the picker to select this orange, and now we can see that this orange is blue and we can further refine the mask. Now let's select one last orange. Let's do this orange, the one hidden behind. Using the picker, let's select this orange and let's scale it down. And we can now also manually adjust the mask. Another way we can use this is maybe we want to add lights to the scene. Or maybe we want to highlight certain parts of the scene. Or maybe even dim certain parts of the scene. So let's brighten this cake. To create the light, we will use another color corrector node after this one. Just for a moment, let's disconnect the depth blur. And in the color corrector, let's increase the gain and gamma. Let's load another volume mask node. Connect the position pass to the volume mask and then the volume mask to the color corrector. In the volume mask, we can go to color and select mask only. And we will use the spherical shape. Then we will pick and drag on top of this area of the cake here. Alright, we need to connect it to the effect mask. Now let's reduce the size to 0.1 and soften the edge to about 0.5. Finally, let's drag it down in the y-axis. Now we have brightened up our cake. Now, what else can we do? Well, there is another position tool called Volume Fog. And it does exactly what its name says. It creates a fog. To load it, go to Add Tools, Position, and we're going to select Volume Fog instead of Volume Mask this time. The volume fog creates sophisticated volumetric fog on images containing XYZ position channels. Most of the tools that we will be using in the volume fog is in the shape tab here and the color tab. Now let's zoom closer. It needs an image. The volume fog node needs an image containing XYZ position channels. In the fog image input, we can use a fast noise node to create a fog texture. We can add a mask in the effect mask input, but the last and the most important thing that this node needs is a camera data, without which it will not be able to accurately generate our fog. So first let's add the position pass into the scene. We will use the channel Boolean method and connect the image into the background input, and then connect the position pass into the foreground input. And if we press Alt and click this wire, we can create this bend to better organize our node structures. In the Boolean node, we will select RGBA to do nothing, and in the aux we will add XYZ position channel to the XYZ respectively. Now let's have a look. X is correct, Y is correct, and Z is also correct. And that's because we have already corrected our data in the position pass node, so we don't need to correct it in the channel Boolean node. Now let's connect the channel Boolean node to the image input of the volume fog, and over here we can see some fog mist thing in our scene, and we can use the picker to place this fog anywhere in the scene. So let's move it all the way to the back. Now let's scale it up. Now the reason why it's not working as we expected is because we have forgotten to give it a camera data. Now we can use the Fusion 3D camera, but it's preferable to use the camera that was used for the 3D scene. So here I've already imported the camera, but if you want to know how to do it, you can go to File, Import, and then either select Alembic or FBX depending on how you have exported it. So let's connect the camera to the volume fog, and in the volume fog go to the camera and select the camera that we are using. That's because you may be working on a 3D composition that has several different cameras. So the volume fog needs to understand that this is the camera that you want to use to create the fog. Now, let's reposition our fog and increase the scale to 50, and let's dial it down into place. Now we can change the color as well, so let's choose a warm color. And finally, let's go to settings and blend it back just enough to create a sense of depth in the scene. Now, let's connect the volume fog to the depth blur. Now let's set the focus on, let's set this cake over here. And this is how we use Z-depth and position pass in Fusion. Now let's make this scene even more interesting. Let's add a glowing ball of light that floats on the table and hovers over the coffee cup for a while and then floats away. And what we are going to do is that we are going to use the position pass to create the illumination from the glowing ball on the table, and also animate the focus to follow the ball of light. Okay, so this is the animation that I've created. This is the small ball of light. It's just floating on the table following a path. And what we need to do now is to add illumination on the table and animate the depth of field. First, let's have a look at what a ball of light is made of. Here we have a background node which is of yellow color, and we used an ellipse mask to create a circle. Then we added soft glow on top of that, and then we used a transform node to animate it, and this is its path. We then smoothen the animation in the spline editor, except for this area where we have to use linear because the ball of light is hovering here for a while. Now, if we look over here, we can see that the ball of light is going in and out of the scene. To solve that, what we did was add another background node, and this background node is transparent, and it has an image resolution of 3840 by 2160, which is the same image resolution of our composition. Then I connected them to a merge node with the background in the background input and the ball of light in the foreground input. Now it fits the scene, and we can see it scaling up as it comes closer. Finally, we added another soft glow node just to make it brighter. and then we merged it with the beauty pass. Now, let's create the illumination on the ground as the ball travels. So first, switch off the depth blur. We will be adding it later. And we have also switched off the volume fog because we will not be using it for this scene. Now, let's move the depth blur over to this side and connect the volume fog output to the merge node. Now we will use the position pass and the volume mask node to create the illumination area. Next, we will add the color correction node, and in the color correction settings, first we will change the color to a bright yellow. Next, we will increase the contrast very slightly and increase the gain to about 2.4. Finally, we will increase the gamma as well to about 1.5. And this is going to be our illumination. Now what we want is for this ball to emit light, and when it emits light, it's going to highlight the area in the scene, including objects. Now, if we are just using polygon mask, we can see that it is not honoring the object position, curvature and depth. So how do we create a mask that honors the object's position, curvature and depth? For that, we are going to use a position tool called volume mask. Now, let's add a volume mask node. Let's connect the position pass to the volume mask and the volume mask to the mask input of the color corrector. Let's split the screen and we'll load the volume mask over here. Let's go to color and we are going to use mask only. In the shape, we will select sphere. Let's reduce the size to about 0.42 and we'll soften the edge to 1. So this is our illumination mask, and we will position this just underneath the ball of light. And what we will be doing is, let's go to the transform node. We will be using these keyframes as a guide to place our illumination mask. So let's go to frame 0 and we will add a keyframe to the translation. And then using the picker, we will position the illumination mask directly underneath the ball. Let's check in the translation. Yes, okay. So we can see that the next frame is 20 frames forward. So let's go to frame number 20 and let's reposition the illumination mask, and it will automatically add a keyframe. Here, we will manually move the mask to get it just behind the cake. Now let's go 20 frames forward, and here we are going back to that orange and then use the picker to select just underneath that orange. Now let's go 20 frames forward and let's reposition it. And then another 20 frames forward, let's reposition it over here. And after another 20 frames, we will reposition it again, this time just behind the apple, and we will use the same technique that we used for the cake. Now let's go 20 frames forward and let's do this again. Finally, 20 frames forward and we position the illumination just on top of the coffee cup. And we are going to make it stay here up till frame 160. Here we'll have to manually add the keyframe. Next, let's go to frame 180 and let's move the light out of the frame. Now let's have a look, and I think we need to add some in-between frames. So at frame number 130, we'll bring the illumination just underneath it, and then we will add another illumination in between at frame number 170. So this is what our animation looks like currently. Now, over here when it comes on top of the coffee cup, we don't want the illumination to illuminate in front of the cup. So to correct that issue, what we're going to use is we'll use a bitmap to control the spill. And at frame 140, we will adjust the high and low value until it's just illuminating the inside of the cup. And I think we need to reposition the mask as well. So let's do that. And I think that should do it. Now let's copy the value and paste it at frame 160. Now let's go back to the bitmap and we will add a keyframe to the high and low value at frame 160 and at frame 140. Now let's go back a few frames and reset the high and low values to create a transition effect. Now after this, let's go to frame number 170 and we'll reset the high and low value here as well. And this is what our animation looks like. Now let's animate the depth of field. So one key thing to remember is that we'll have to add the depth of field before our glowing ball, because we want the glowing ball to be in focus. So what we will do is, we'll place the depth of field node before the glowing ball merge node. And now let's go to frame number 0. And using the sample tool, let's select the area just underneath the ball. We need to position the depth of field using the table as a guide, because the ball is not part of the Z depth data. So if we try and select the ball, the Fusion will think that we are trying to select something that's behind it. So to keep the ball in focus, we need to select the area underneath it. With that selected, let's add a keyframe to focal length. Now let's go to frame 20 and we'll use the sample to move the focus. In this case, we can select the top area of the cake. No, in fact, let's select the back side of the plate. And then let's move for 20 frames and let's do it again. Well, you get the idea. So let's fast forward the process. Now, I had changed the blur style to box, so let's change it back to super soften. And this is what our final animation looks like. So we have learned how to use Z-depth to create a depth of field, and we have also learned how to use the position pass to create all of those various effects. Now, what if we were in a situation where we don't have a position pass? We may not have rendered it out, or we just don't have it for some reason or the other. What do we do in that case? Well, there is a very nifty tool in Fusion that uses the Z-depth data and the camera to recreate the world position pass. So let's have a look how we can do that. This is a composition from a documentary that I made called Postcards to the Unknown Child. If you want to watch the documentary, you can click on the link above. This composition does not have a position pass. So now let's have a look at what we can do about creating a world position pass when we don't have one. What we will need is a Z-depth pass. Fusion has a node that can very easily create a world position pass. This node is called Z to world position. To load this, right-click in the node editor, go to Add Tool, go to Position and click on Z to World Position. Now, let's have a look at the Z to World Position node. So there are two rows. The first row is called Mode. What this basically means is that, do you want to convert a Z depth to world position? Or do you want to convert a world position pass to a Z depth pass? And in the second row, it is asking for a 3D camera data. So a Z to world position pass needs both the Z depth and the camera data to generate world position data, or a world position pass and camera data if you want to generate a Z depth pass. Now for the camera part, we can either use Fusion's 3D camera if we don't have any, but it's preferable to export a 3D camera from the 3D scene that you are working on. And we can import this 3D camera by going to File, Import, and we can either select Alembic or FBX, depending on how you have exported it. In this case, I will select FBX. Let's search for the camera and then press Open. All of these settings are okay, so I'll continue. Now, we won't be needing the transform data, we just need the camera. And we need the Z depth information. So first we will connect the Z depth to the Z to world position node. Then we will connect the main camera to the camera input of the Z to world position node. Now let's load this into the viewer. And we can see that our node is suddenly turned red. That's because, first, we need to select which camera we are using. The reason is that sometimes we may connect a 3D scene into this node. And that 3D scene may contain many different cameras. And this node doesn't know which camera we want to use. So we need to manually select the camera we want the Z to world position node to take its camera data from. Secondly, just connecting the Z depth image doesn't mean that the Z depth information is being used. To ensure that depth information is being fed into this node, we might need to connect the channel Boolean node which contains depth information. So let's click and drag the output of the channel Boolean node to the Z to world position node. Now let's just create these joints to better organize our node structures. Now let's load the Z to world position node into the scene again. And it still feels like nothing has happened. But if we go over to the color control, we can see the position data available. So this is how we create a world position pass using Z depth and camera. Now let's check if it's actually working or not. So let's load a volume mask node. In the volume mask node, let's select mask only. And in the shape, let's pick a point using the picker. And we can see that, we can't see the point. So let's just increase the size to about 1000. And now we can see our mask, but it's just too big. So let's just scale it down a little. And then we can use the picker to select anywhere in the scene. Now let's just soften the edge and then select the sphere shape. Now connect the volume mask to the composition. Next we will load a bitmap node, and in the bitmap node we are going to press invert because we want to invert the mask. Now back in the volume mask, let's just set the size to about 1280. And in the merge node, let's just blend it all together and select screen. And now we have created a fog effect in our scene. Now this is just an example to show you that this world position pass works. So this is how we can create a world position pass when we don't have any. This is just a basic introduction to Deep Pixel Compositing. We'll go in depth into Deep Pixel Compositing in another tutorial. But that's all for today. Please don't forget to like, subscribe and ring that bell icon. Until next time, see you.